Welcome to this video on integration, and in particular integration by substitution, sometimes called U-Substitution. This method is used to make the integral simple and is used where things in the integrand are derivatives of each other. So for example, if we were given integrate x squared minus 7 squared dx, we could do this the long way round and square what's in the brackets, so we'd get the integral of x to the 4 minus 14 x squared plus 49 dx, and then distribute the x, so we'd get integral of x to the 5 minus 14 x cubed plus 49x dx. And then when we apply the rules of integration, we get x to the 6 over 6 minus 14x to the power 4 over 4 plus 49 x squared over 2 plus c. U-substitution makes this much easier. And what we do in this case is we choose u so that when we differentiate it, that appears somewhere in the original equation. So if we have the integral of x squared minus 7 squared dx, we choose u to be x squared minus 7, du then equals 2x, and we can see that an x appears here. We don't have to worry about the constant 2, we can get rid of that by division. So this now becomes, if we rearrange it, we get x squared minus 7 squared x dx. So we can replace this with u squared. This x dx, we need to replace all the x's, and here we can see the du equals 2x, and here it's x dx, so we need to divide by half. So we put a half on the outside of the integral, and then this becomes x dx is du. And then when we integrate, we get a half u squared du, and this is, so that should be the integral of half u squared du. Then when we integrate, we get a half u power 3 over 3 plus c. When we replace the u with the original, here x squared minus 7, we get a half times a third u to the power 3, which is x squared minus 7 plus c, and that equals 1/6 x squared minus 7 to the power 3 plus c, and that is our answer. Let's go over the rules again of U-substitution just to make it clear in our minds. So we pick an inside function usually to be u, so here an inside function will be x squared plus 4. Sometimes if it's a fraction, we pick the denominator to be u. du has to appear in the original integrand with the variable and or with a constant. Du must be decreasing constants. So those are the rules. So if we have this equation, integral of 2x x squared plus 4 to the power 99 dx, we can't multiply this out 99 times, so we use U-substitution. So on the side here we put u equals x squared plus 4 du equals 2x. We can see the 2x appears in the original integrand, so we can go ahead with our U-substitution. So this then becomes the integral of u to the 99 2x dx. The 2x dx, sorry, that should be a dx there. The 2x dx is nothing but du, so this becomes u to the 99 du. And then when we integrate using our rules of integration, 99 plus 1 is 100, so that's u to the 100 over 100 plus c. The last step, we replace the u with the x's, and we get 1 over 100 x squared plus 4 to the power 100 plus c. And that is our answer. Quickly go over some other examples. Integral of cos cube theta sine theta d theta. U equals cos theta, and du when we integrate becomes minus sine theta d theta. So we can see that if we have u as cos theta, the sine theta appears in the original integrand, so we can use our u substitution. So this then becomes u to the power 3 sine theta d theta Now du is minus sine theta d theta, and when we rearrange that, we take the minus to the outside of the integrand, so that's minus u3, and then sine theta d theta is nothing but du. Then when we use our rules of integration, this becomes minus u to the 4 over 4 plus c. Replacing the u's with our theta values, we get minus cos 4 theta over 4 plus c. Just as an aside, if we go over some differentiation and integration of sine cubed x. So dy by dx of sine cubed x. This can also be written as sine x all cubed using the chain rule, which is dy by dx equals dy by du times du by dx. We bring the 3 down, then the sine x, decrease the power by 1, and then differentiate what's in the brackets, and that is cos x. Integration. So integral of sine cubed x dx. Right, so we have an identity. Sine squared plus cos squared equals 1. From this we get minus cos squared x plus 1 times sine x. If we distribute the sine x into the brackets, we get minus sine x cos squared x plus sine x dx. And this is what we want to find the integral of. This equals because of the plus sign we can split it into 2, so that's minus sine x cos squared x plus the integral of sine x dx. This we already know the integral of is minus sine x. So this is what we want to apply U-substitution to. So this part here. So what we do is bring that over here. So U equals cos x du. When we differentiate cos x, we get minus sine x dx. So here we have a sine x minus sine x, so we're good to go. So this bit then becomes cos squared x is u squared, so this becomes the integral of u squared du. And then when we apply our rules of integration, we get 1/3 u to the power 3. And then don't forget our minus cos x, from here. So u to the power 3 minus cos x. Then when we replace the u, we get 1/3 cos x minus cos x. Another integration, so integration, the integrand x of x plus 2. So let's choose a u value, and usually we use what's in a bracket or what's underneath, or what's underneath the cube root or the root. So that's x plus 2 du is the x disappears. That's tx. Now the problem we come across is the x is left on the top. Let's rewrite this. Again, that's the x, and this then becomes x plus 2 to the 1/3. So this is u to the power 1/3. So what can we do with the x? Well, we have x, we want to replace it. We can't be left with any x's, so we can use u equals x plus 2, and we get x equals u minus 2. So we replace the x with u minus 2. Now, because we have a single term on the bottom and a plus or minus on the top, we can split this into 2. So this becomes the integral of u to the u 1/3 minus 2 to the u 1/3 to u. Now what we can do is we can do the separate integrals. So this then becomes integral of u, bring the 1/3 up, it becomes 2/3, 1 minus 1/3, minus the integral of 2, and this bring the u to the 1/3 up, so it's u to the minus 1/3 du. When we do the actual integration, then add 1, u to the 5/3 over 5/3 minus 2 u minus 1/3 plus 1 is 2/3, so that's over 2/3 plus c. Rearranging, we get 3 u to the 5/3 over 5 minus 3 times 2 u to the 2/3 over 2. This becomes 3/5 u to the 5/3, and this becomes 6 divided by 2 is 3 u to the 2/3 plus c. And then when we replace the u's with their original values over here, x plus 2, this becomes 3 over the 5th, x plus 2 to the 5/3 minus 3 x plus 2 to the 2/3 plus c, and that is our answer. Integral of 6x x squared plus 4 to the power 3 dx. Let's pick a u, usually what's in the brackets, that's x squared plus 4, du is 2x dx. Now we don't seem to have a 2x in the original integrand. What we can do is we can make one up, so we'd have 6x equals 3 times 2x, so bring the 3 to the outside, this will become u to the 3 2x dx. Now the 2 dx is here, so that becomes u, so this becomes integral of 3 u to the power 3 du. Now let's do the integration, apply the rules. We get 3 1 over 4 u to the power 4 plus c, and that becomes 3 over 4. Replacing the u, we get x squared plus 4, which is here, to the power 4 plus c, and that is our answer. Integral of ex plus e to the x dx. Sounds quite complicated, but let's tackle it. Let's rewrite this using our combining bases powers rule. So this then becomes integral of e to the x divided by e to the x dx. We let u equal e to the x, so that's this one, and let du, well, du would still be e to the x dx. When we replace, this becomes e to the u du, and when we integrate, e to the u is e to the u plus c, which equals u was e to the x plus c, and that is our answer. Okay, in this example of integration by U-substitution, we have cot x natural log of sin x dx. So we choose u to be something in the brackets, which is natural log of sin x. Du then would equal 1 over sin x cos x. When we rearrange that, that's cos x over sin x, which is nothing but cotangent of x. So we can see that cot x appears in our original integrand, so we can use U-substitution. So this then becomes the integral of u cot x dx. Cot x dx is nothing but du, so this becomes the integral of u du. So now we've got everything in terms of u, all the x's have disappeared. Now we can do our integration. So this becomes u squared over 2 plus c. Now we replace the u's with our x's to get back to our x's, so we get u is natural log of sine. So u squared becomes natural log of sine x all squared over 2 plus c. Sometimes when we're doing integration by U-substitution, it doesn't matter what we use as the u, so long as when we're doing our initial u and du, the du appears in the original integrand. Let's have an example of that. So that we're going to choosing a u. So for example, if we have the integral of sine 3x cos 3x dx. So in the first case, let's use u as sine 3x, and our du then becomes the differentiate that, we get cos 3x multiplied by 3. So we can see that the cos 3x appears in our original integrand, so we can use this substitution. So this becomes 1/3. The integral of sine 3x becomes u, and our cos 3x dx, which remains, that becomes du. So this then becomes 1/3 u du. When we integrate that, we get 1/3 u squared over 2, so that's a half u squared plus c. And then when we replace our u with our original x's, we get 1/6, 1/3 times, that is 1/6. The u is sine 3x, and that's all squared plus c. Now for the same sine 3x cos 3x dx, if we were to choose u to be the cos 3x, du then becomes minus sine 3x 3 dx. So there should be dx there. Minus sine 3x 3 dx. So we can see the sine appears in the original integrand, so again we can use this substitution. So let's do that. So this becomes minus 1/3. The cos 3x is the u, and we're left with the sine 3x dx. The sine 3x dx is the du, so this becomes the integral of minus 1/3 u du. And when we integrate this now, because we've got rid of all the x's, this becomes 1/3 minus 1/2 u squared plus c. And when we replace the u with the cos 3x, we get minus 1/6 cos 3x all squared plus c. And both this and this answer are the same, both are correct. Integral of sine 1 minus x 3 minus cos 1 minus x to the power 4 dx. So let's choose something to be the u. So u equals 3 minus cos 1 minus x. So that's the stuff in the brackets. We chose that to be u. So du equals this differentiating minus cos, we get sine 1 minus x dx. So we can see the sine 1 minus x appears in our original integrand, so we can use this U-substitution. So the integral then becomes u to the power 4, so this is all u to the power 4, sine 1 minus x dx. Sine 1 minus dx is nothing but du, so this becomes the integral of u to the power 4 du. Now that we've got rid of all the x's, we can do our integration. So this becomes 1/5 u to the 5 plus c, and when we replace our u with our original, we get 1/5 3 minus cos 1 minus x to the power 5 plus c, and that is our answer. Let's have a go at another one. The integral of sec squared 4x 3 minus tan 4x to the power 3 dx. Let's choose our u to be what's in. Usually we always choose what's in brackets, so this would be 3 minus tan 4x. Our du would then be minus sec squared 4x multiplied by 4. Or another way of writing it would be, if you wanted to, minus 4 sec squared 4x dx. Now we can see that the sec squared 4x appears in our integral, so this becomes minus 1/4 integral of, which is u power 3, and then our sec squared 4x, we've moved the minus over here, is du. So this is the integral of minus 1/4 times 1/4 u to the power 4 plus c, and when we replace our u's with our original 3 minus tan 4x, we get to 1 over 16 3 minus tan 4x to the power 4 plus c, and that is our answer. Integral of 1 minus 1 over t cos t minus natural log of t, and we have that dt. So that's our integral. So or choose what's in the brackets first of all, see how that goes, natural log of t. So our du then becomes 1 minus 1 over t dt, and dt equals du over 1 minus 1 over t. So when we replace this in here, this becomes cos of u, and then we're left with this, which is 1 minus 1 over t dt, and the 1 minus 1 over dt is du, so that's nothing but the integral of cos u du.